Hello, in this video we're going to look at how we can find the area of a segment of a circle. And remember, a segment, if I show you up here, if you have an entire circle, you could draw a line across like this line would be a chord, and this area in here is the segment. Or if you had a sector, then the line would be drawn across here, and it's this area which is your segment. So these are segments, and in this video we're going to see how you can find the area of them. And to do this, you often use, or not always, but you're often going to have to use the sector equation, the area of a sector stuff that we learned in the last video. So if you haven't watched the last video yet or not comfortable with that, then I definitely recommend doing that first. Anyway, with that out of the way, let's have a look at the exact question that we have. So it says the arc AB of a circle with a center O and a base of 12 centimeters is such that the angle AOB is 0.25 radians. And for part A, we have to show that the area of the sector is 18 centimeters squared. So that will be using the formula that we learned in the last video. And then for B, we have to calculate the area of the segment that's enclosed by the chord AB and the minor arc AB. Yeah. So don't worry about B too much in the moment, let's just focus on A. The first thing we want to do is write out our formula for the area of a sector, which is 1/2 r squared theta. And we want to sketch it out, so draw out the diagram. So this here is a sector. Yeah, it looks a bit like a pizza slice or an ice cream cone. And then we have A and B, which are 2 points on the circumference. And we have this little arc between them. And we have the origin O. So then to label it, the angle here is 0.25 radians. So we can put 0.25 down here. And then this radius is 12 centimeters, 12 centimeters. So all we have to do here is 1/2 times the radius of 12 squared multiplied by the angle of 0.25. Pop that in the calculator, and that will give us 18 centimeters squared. And that's it. So we've done the first part. We've said that A is 18 centimeters squared. That is the area of this whole thing. Okay, so now we can move on to part B, which is where we have to calculate the area of the segment that's enclosed by the chord AB and the minor arc AB. So looking at our diagram, if I draw a line straight from A to B, that is a chord. That there is the chord AB, because it stretches from one point on the circumference to another point, and it goes straight through the circle. And then this here is the minor arc AB. So we want this area in here. That's what we're looking for. And to find that, there isn't really an equation. I mean, there sort of is, but instead of thinking about it as one equation, you sort of want to think, what's the area of this entire sector? And then take away the area of this bit here. Yeah. So if we scroll down, to find the area of a segment, you do the area of the entire sector, which remember is 1/2 r squared theta. I mean, and we just worked that out to be 18, so we don't really need to write out this formula, but I just wanted to show you. That's 18. And then we have to minus the area of this triangle here. And remember, to find the area of a triangle, if it's a kind of tricky one like this, you have to do 1/2 AB sine C. Yeah, where A and B are two sides on either side of the angle C. So in this case, that would be 1/2 times this side and this side, which will both be 12, so it's actually 1/2 times 12 squared, times sine of 0.25. Sorry, it's not quite enough space there to write, but 0.25. And if we work all that out, if we put all that in the calculator, 18 minus all of that, that gives us 0.187. So that there is the area of our segment. And like, I know that seems pretty small. Often it will be quite small compared to the area of your sector, because you're only looking for a very tiny segment of it, or only a tiny part of it. That's it. So if you look up at the formula for the area of a segment, they may give you all of this. That's why I wrote this row. Like, they'll say that this here is the formula for the area of a segment. But personally, I find that kind of a pain to remember this because it's a massive formula. Whereas if you just understand that to find a segment, you just do the area of the whole sector minus the area of a triangle. And all you have to do really is combine these two equations that you already know. Yeah, you have to know these two individually, so you may as well just understand what this is and write it out like this each time to get your answer. I wouldn't try and memorize this whole equation here as a formula. And the last thing I would say is make sure that your calculator is in radians when you do sine of 0.25. Just remember, you have to convert your calculator from degrees to radians. Otherwise, this will give you a weird value and you wouldn't get the same answer as me. But yeah, anyway, I hope that all makes sense. If you have any questions, just let us know. And otherwise, have a go at some of the MCQs and just give it a good little practice. I'll see you next time. Thanks.